This video will cover the procedure for the river health evaluation piece of the Benthic Macroinvertebrates volunteer program with CRWA. This video should help increase your confidence in your evaluation and understanding of each of the parameters for the evaluation. But first, let's start with the bugs. Benthic macroinvertebrates are small aquatic animals with no backbone. We can see these creatures with the naked eye. Many benthic macroinvertebrates have a relatively long lifespan, which means that studying them gives us a longer-term picture of the river's health. Additionally, although the animals that we collect are sacrificed, benthic macroinvertebrates are plentiful, and sampling these creatures will not make a significant impact on the river or its health. The sampling you do provides an evaluation of the health of macroinvertebrates and, by extension, the Charles River and its watershed. In order for a river to be healthy, it should support diverse aquatic life, meaning lots of macroinvertebrates of different kinds. But these creatures aren't all we consider when evaluating the health of the river, so let's get into it. A more direct way of evaluating the river's health is by making observations at the site of the sampling. That is the habitat assessment. We do this by splitting up the evaluation into 10 different parameters. These include bottom cover, pool bottom, pool variability, sediment deposition, channel flow, channel alteration, channel sinuosity, bank stability, riparian zone, and bank vegetation. Let's break them down. Welcome to the Dix Brook sampling site. First on our list is bottom cover. Bottom cover refers to the natural structures in the river like riffles, sand patches, and large rocks. Riffles are places where the water rushes over rocks, often causing sounds like this. So, bottom cover refers to what is on the bottom of the river or stream. Ask yourself, what different kinds of soil, sand, or rocks make up the bottom of the river? The river is more healthy if there is a variety of riffles, sand, and large rocks at the site. At the Dix Brook site today, we decided to rate pool bottom optimal. The next parameter is pool bottom. Pool is a structure in the river with little or no current. Pool bottom and bottom cover sound similar, don't they? So let's go over the difference. First, bottom cover refers to the makeup of the bottom of the stream or river. Bottom cover is about whether there are stones or sand at the bottom of the river, or in other words, what makes up the bottom of the river. Pool bottom is more general, and is asking about how solid the bottom of the pool or pools are. Do you sink if you stand in the water? The softer the soil or sand on the bottom of the pool is, the worse the condition of the area. Ideal pool bottom conditions would be when the bottom of the river or stream is sturdy, and vegetation is growing up from the bottom. Vegetation on the bottom or root mats indicates that the area can support natural life. At the Dix Brook site today, we decided pool bottom was in optimal condition. For this parameter, it's important to know that before you can evaluate pool bottom, you will have to identify the pools at your site. Next up is pool variability. There are 4 basic pool types that we use for this evaluation: large shallow, large deep, small shallow, and small deep. We consider pools less than a meter deep to be shallow. Therefore, a pool that is more than a meter deep would be in the deep category. Rivers with just 1 or 2 of these river pool characteristics are not considered healthy because they don't support the variety of microhabitats that other areas might. These microhabitats are in different pools and river structures, and the presence of a variety of microhabitats determines the diversity of aquatic life at the site. Today we rated Dix Brook's pool variability suboptimal. The sediment deposition parameter measures the amount of sediment accumulated in pools and evaluates changes that have occurred to the stream bottom as a result of deposition. Large-scale sediment movement produces deposition, which may fill runs and pools, reducing habitat diversity. Today we rated sediment deposition at Dix Brook as suboptimal. Channel flow is the degree to which the channel is filled with water. When the water coverage is low, the diversity of aquatic life is likely to be low as well. Channel flow will change over time because of dams or other obstructions, diversions for irrigation, or drought. The river is less healthy if there's less water in the channel, because if there's no water, the river can't support aquatic life. We have seen this channel much more filled with water. Here is the same stretch today versus a few months ago. We rated channel flow marginal. Channel alteration measures the large-scale changes in the shape of the river over time. These changes could be a result of things like bridges, dams, artificial embankments, or concrete channels. Altered streams have fewer natural habitats for aquatic organisms, meaning they don't support diverse aquatic life. Here at Dick's Brook, there is not much sign of human impact. We rated channel alteration optimal. Similar to channel alteration, channel meandering, or channel sinuosity, evaluates the bends in the stream. Stream bends absorb the energy from storm flows and protect the stream from excessive erosion and flooding. Erosion is the gradual breaking down of land from water flow. In mild cases like this one, it might look like this, while in more severe cases, it might look more like this. The river also provides refuge for benthic macroinvertebrates and fish during storms. Channels and bends will naturally evolve continuously, but a stable channel does not exhibit progressive changes in slope, shape, or dimensions along its length. A high degree of sinuosity or meandering provides diverse habitat and fauna that indicates good health of the river. Today at Dick's Brook, we rated channel sinuosity suboptimal. The parameter for bank stability evaluates the erosion of the banks and the potential for future erosion. Steep banks are likely to collapse and are considered unstable. Eroded banks indicate a problem of sediment movement and suggest a scarcity of cover and organic inputs to streams. Here are some signs of erosion to look for at your site: unvegetated banks, crumbling, exposed tree roots, and/or exposed soil. Each side of the bank is evaluated separately for the evaluation, and the cumulative score from right to left is used for this parameter. To determine the right bank from the left bank, look downstream, or in other words, the direction that the water is flowing to, not from. Today we agreed the left side was suboptimal, while the right side was optimal. The riparian zone parameter measures the width of natural vegetation from the edge of the stream bank through the riparian zone. But what is the riparian zone? For our purposes, the riparian zone is the section of land that the river operates on. For this program, typically the riparian zone is measured with a tape measure and is about 100 feet in length, starting from an existing river abutment or other indicator at the habitat site. This means that for this part of the evaluation, you will need to walk away from the river and look for signs of human impact like roads, buildings, dams, or bridges. A wide, undisturbed riparian zone supports a robust stream system, which buffers pollutants entering from runoff, controls erosion, and provides habitat and nutrient input. Each bank is rated separately, and the cumulative score is used for this parameter. We rated riparian zone suboptimal on the right and left banks. The bank vegetation parameter evaluates the amount of vegetative protection the stream bank has, as well as the near stream portion of the riparian zone. We look for this because roots can help hold soil in place, thereby reducing the threat of erosion. Bank vegetation can also uptake nutrients, control the damage of high-speed water flow, and provide organic inputs and shade for temperature control. Banks that have full, diverse, and natural plant growth support diverse aquatic life. Each bank is evaluated separately for the evaluation, and the cumulative score is used for this parameter. At Dick's Brook today, we rated bank vegetation suboptimal on the right and left banks. For the final habitat assessment score, we will add up the numbers from each of the parameters we examined. If we agree that all these parameters are as good as possible, the number will add up to 200. 200 is the highest possible score. Be aware that this information is subjective when applied. We can only ask that you use your best judgment when doing the habitat assessment. Please note, do not study just one section of the riparian zone for your evaluation. For a thorough evaluation of the river's health in this area, you will need to walk the length of the entire riparian zone and also consider the surrounding area. Thank you for your time and devotion to the health of the Charles River watershed. Good luck evaluating!